And hello everyone, welcome. So in the video we will talk about transmission line equation from transmission lines and waveguides. So in here already you know that the transmission line there is a two-port network. So on the two-port network resistors then inductor here also resistor and also inductor. In this gap is called it as output voltage V. So this is also called it as input voltage V plus dV. So based on that, we are going to derive the equation for transmission line. That is also called as a general equation. So the input current also they mentioned I plus dI. The output current also it mentioned I. Output current also it mentioned as I. So already you know that in the transmission line, electrical energy transfer from electrical energy transfer from one place to another place. Electrical energy transfer from one place to another place. That means one location to another place. Electrical energy one place to another place transfer agum. That is called as electrical energy transmission system. So in the transmission system, then T section to look like as a T. Your resistor R L your R L your R and C so look like as a T. So it's also called as a T section transmission line systems. Then finally uniform transmission system also available. So uniform transmission line is also infinity number of transmission lines are there. If it is a uniform transmission line, infinity number of transmission lines are available. Infinity number of transmission lines are available. It is called as a uniform transmission. Then each transmission line consists of length. Transmission line consists of length with dx. So each transmission line consists of length with dx. Consists of a length with dx. So this is called as a transmission line basic informations. So now I am going to go for next page. Transmission line the system. So here what is the input voltage? That we came to know. What is the input voltage? Then what is the output current? Our objective is we are going to take current. So output current. So input voltage so we mentioned as here V plus dV. Input voltage is called as V plus dV. In the output current here we call it as I. So output current is I. So based on that input voltage and the current, we need to calculate the impedance and admittance to find impedance and admittance. To find impedance and admittance symbols are this is wrong one. To find impedance and admittance. So here the impedance is called as series impedance. This is series impedance. Clear? Then this admittance is called as shunt admittance. Understand? So these are very basic important things. Then based on the impedance and admittance value, we are going to calculate the characteristics impedance and the characteristics admittance. Okay, so from the last video, everyone knows what about what is the value of z. Z equal to r plus j omega l. So it is called as a, if it is a unit impedance, you have to multiply with 1. So z equal to r plus j omega n. The same thing in the admittance also, admittance equal to g plus j omega c. G plus j omega c. We need to consider both are in unit impedance and admittance. Unit impedance and admittance. So this unit impedance admittance with the unit length, call it as impedance and admittance value. So after that, the same impedance admittance we can consider as here length dx. With the help of length dx, that means you need to multiply with both impedance and admittance value, r plus j omega l with dx, then admittance g plus j omega c with dx. So this is called length with dx. So after that we can use this both impedance and admittance value. By help of this impedance and admittance value, we will find voltage drop or potential difference between two ends. So finally நம்ம என்ன பண்ண போறோம் அப்படினு பாத்தீங்க அப்படினா, இங்க வந்து voltage drop and or potential difference between two ends. So what is the potential difference value? PD equal to potential difference between the two ends. Already we know that V plus dV equal to minus V is equal to I into R plus J omega L into dx. PD equal to V plus dV minus V. It is equal to I into R plus J omega L into dx. So after simplify this equation, V and V going to cancel. Finally dv by dx equal to I into R plus J omega L. I into R plus J omega L. So already we know that this R plus J omega L equal to Z. So after that dv by dx equal to I into Z. dv by dx equal to I into Z. So this is the value for potential difference between the two nodes. dv by dx equal to Z. So this is the value for the value of the potential difference between the two ends. After that we are going to calculate current equation. After that we are going to calculate current difference between two ends. So like I plus di minus I is equal to V into G plus J omega C multiplied with the length dx. So the same thing I and I going to cancel. So here instead of dv by dx, here we can use di by dx equal to V into G plus J omega C. So already we know that G plus J omega C equal to G plus J omega C equal to impedance. So automatically it will come di by dx equal to V into Z. So already we derived one equation like first second equation. This is called as a second equation IZ. This one is called as a third equation BZ. So now we know that current value and voltage potential difference value. So after using this equation, we can differentiate the equation first like dv by dx into IZ. And the equation நம்ம என்ன பண்ண போறோம் பாத்தீங்க அப்படினா differentiate பண்ண போறோம். So IZ value இந்த equation நம்ம என்ன பண்ண போறோம் differentiate பண்ண போறோம். So for solving and getting some values, so differentiating equation like second equation r plus j omega l, r plus j omega l into I. So like that equation r plus j omega l. So this equation is called as r plus j omega l into I. So in the first equation நம்ம already we can see that இத வந்து நாம என்ன பண்ண போறோம் differentiate பண்ண போறோம் with respect to b. So here d squared b by dx squared equal to r plus j omega l multiplied with differentiation of di by dx. So already we know that what is the value of di by dx. So already we know that what is the value of di by dx. From equation number 3, the value of di by dx is, so from equation number 3, the value of di by dx is z. So you can apply by dx by, already we know that the value of di by dx. So di by dx equal to v into z. That means v into I. I means g plus j omega c. So now I am going to differentiate. Equation number 2. So what is the equation number 2 for differentiation? So already we know that equation number 2 is di by dv by dx. This one, dv by dx equal to I into r plus j omega l. So r plus j omega l. So here we will shift into di by dx. Already we calculated dv. The same thing we are going to calculate di by dx. So d squared I by dx square is equal to g plus j omega c into dv by dx with respect to voltage. So already we differentiated with respect to current and differentiated with respect to voltage. Now what is the value for this value? G plus j omega c and r plus j omega l with respect to I. So this also we got by using differentiation method. So next steps we are going to calculate propagation constant. So already we know that propagation constant gamma equal to root z comma y. So already we know that root of z and y value r plus j omega L G plus j omega C. These are values are belongs to propagation constant. So propagation constant gamma equal to R plus j omega L G plus j omega C. So இங்க வந்து பாத்தீங்க அப்படின்னா gamma squared பண்ணீங்கன்னா அதோட root வெளியே வந்துரும். So R plus j omega L in the bracket G plus j omega C within the bracket. So this also considers another new equation. This also considers another new equation. Now we need to apply this value in the new equation, equation number 3. So already we know that equation number 3 with respect to voltage. Where is the equation number 3? di by dx equal to Vz. di by dx equal to Vz, and then dv by dx. Where is the dv by dx? This is the dv by dx equal to I into z. So instead of this value we are going to apply di by dx equal to V into z. So here we can apply this value. Similarly, both value we are going to get after substituting of this value. So by applying a d squared v, by applying d squared v, so in the d squared v by dx form, you get d squared I by dx. So in the equation நாம solve பண்ணோம் அப்படின்னு பாத்தீங்க அப்படின்னா இங்க gamma square into V with respect to voltage, gamma square into Z with respect to I. So that means, sorry, not Z, I. So these three equations also another new equation we got it. So now by using this equation we can take for linear equation. By help of linear differential equation, by help of linear differential equation we will get the general solution of transmission line. That we will see in the next video. So what is the linear differential equation? V equal to a into e power gamma x plus b into e power gamma x minus, and then I equal to c into e power gamma x plus abcd d into e power minus gamma x. By help of this equation number 5 and 6, then by help of this equation number 5 and 6, we will derive the general solution or general equation for transmission line. That we will see in the next video class. Thank you, my dears. Thanks to support. So if possible, consider my request, subscribe to my channel, and also if it is very useful for GATE examination students, we will go for some examples problem also in future video. Okay, so kindly forward to your friends if it is a very useful for yourself. Thank you, my dears. Thank you once again. We will see in the next update videos.